Hey, what's up? We're going to do section 3-1. We did a notes section and a homework section. We're going to do one more homework section. I'm going to do a couple problems with you at the beginning of this new homework section, and then I'll give you what you need to do to finish it off. So let's look at problem number 31. We're on page 287. All right. Let's see. The problem says state whether it is growth or decay. Describe its end behavior using limits. So growth, decay, end behavior. Okay, the problem is f of x equals 3 to the negative 2x. F of x equals 3, that's the negative 2x power. Go ahead and try that, sorry. Okay, we're back, let's see. Growth or decay and behavior. I'm going to start by graphing it. All this can be seen pretty quickly by looking at the graph. So 3 to the negative 2x power. Let's be, whoops, what am I doing there? Let's be careful here. 3 to the negative 2x, whoops, we need to go to y equals 3 to the negative 2x power. And let's graph this. Okay, we can see this is a decay function, is going down. As x goes to negative infinity, the function value approaches infinity, and as x goes to the right towards positive infinity, the function is going to 0. So that's all the answers there. The base here was 3, and so we would think that that would be growth because it's greater than 1. But if you take 3 to the negative 2 power, so there's just an x up there, 3 to the negative 2 power, well, 3 to the second power is 9, and then a negative means the reciprocal. So this really means 1/9 here. That's why it's a decay function if you do that. Okay, so this is decay. And we need to describe using limits, right? Yeah. Limit as x approaches negative infinity. The end behavior is as x approaches the infinities. Okay, well, as you go toward negative infinity, this one approaches infinity, and this one approaches 0. So there is 31. I'd like to next try 37. And let's get the problem down here. Solve the inequality graphically. So we're going to graph 37. 1/4 to the x is greater than 1/3 to the x. Solve graphically. 1/4 to the x is greater than 1/3 to the x. Okay, just going to go ahead and put that in. So I'm going to raise this to the x power. So 1, parentheses, 1/4 to the x, probably would be easier just type 0.25, and 1/3 to the x. I did it again. That's lovely. Okay, and I want to know when the first line is greater. And I'm going to zoom decimal here because I don't know how much. Okay, there's 1/4 to the x. That's the first function. And there's the second function. It looks like 1/4 is greater until you get to 0. They cross over each other. Let me put this in here a little differently because I couldn't really see that very well. Let's go ahead and say, when is this one greater than this one? So when is y1 greater than y2? When is y1 greater than y2? y1. So I'm using the vars button, and now I'm using test, which is above math. It's greater than y2. And I'll just put that on there as well. So it is greater, 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 and then it stops at 0. So So when is it greater? When x is less than 0. Okay, there is 37. Two more. Let's look at number 44. Number 44. It says use a grapher to graph the function, find the y-intercept and horizontal asymptotes. So number 44, find y-intercept and horizontal asymptotes. Find the y-intercept and the horizontal asymptotes. So g of x equals 9 over 1 plus 2e to the negative x. Goodness gracious. 1 plus 2e to the negative x. Okay, so go ahead and graph it on your grapher and find those things. I'll pause this and give you a minute. Alrighty, let's see here. 9 over 1 plus 2e to the negative x. 1 plus 2e to the negative x. And I think that will do it. Well, I can see the y-intercept is 3. And I can hit trace and 0. And yes, the y-intercept is exactly at 3. Let me see. I need to find the asymptote over here. Looks like it is 0. What's the other asymptote going to be? Let's zoom standard. I guess I could just zoom fit, right? Oh, that's pretty cool. So it looks like it's at 9. Okay, and I see the number 9 there, my problem. So I think I'm right. Let's trace over to 10 there. Okay, and you can see at 10, it's 8.999, so that looks good. So my y-intercept is 3. My asymptotes are y equals 0 and y equals 9. So the y-intercept is 3. And the horizontal asymptotes are y equals 0 and y equals 9. Okay, if you want the graph of a flat line, it's just y equals whatever that is if it's going across. And I could throw that on there as well. I'm not going to do 0 because it's already the axis, but y equals 9, that is that line right there. This is the line y equals 0. One more, number 52. Let's get this problem down. Using the data in table 3.7 and assuming the growth is exponential, when would the population of Columbus surpass 800,000 persons? So 52, we're going to use the data in 3.7. And I guess I can go ahead and write that down. So this is exponential growth. Okay, Columbus is, in 1990, it is 632,910. And in 2000, it is 711,265. Okay, there are a couple different ways to do this. I would say you really could just use regression. So try the stat edit thing and see if you can get it. When is this going to be a million? No, when is it going to surpass 800,000? When will it surpass 800,000? Okay. There we go. Go ahead and try that out. I'll pause this and I'll come back to you in a sec. Okay, we're back. Let's go ahead and try this on our calculator. So stat edit, I'm not going to do 1990 and 2000. I'm going to do 0 and 10. Just makes the numbers come out a little nicer. 632,910 and 711,265. Okay, stat, calc. There we go. Okay, so logistic regression. Okay, we talked about the logistic function. That's what it would be. But this is exponential. So let's put that in y1 so we don't have to type it again. And this is the form we were using. So the initial value is 632910, the value of A, which is what it should be. And the growth factor is 1.01. You just kind of ignore the 1, and that's the growth rate. It's increasing at 1.17% per year. Percent per year. Yeah. So that is the growth factor there. It's by a little bit each year, but over 10 years you add almost 100,000 people. So when is this going to be? 800,000. Let's look at, let me get rid of that. Let's look at the table. Okay, 10. So this is the year 2000. 20 will be another 10 years. This will be 20 is at 2010. Still not at 800,000. Oh, there it is. When x equals 21. So this was x equals 0, x equals 10. At x equals 21, that will be 2011. So it should have just passed in real life if this model holds. So there's number 52. Okay? Your assignment, I want you to continue working. Continue working. 33 through 57. Let's go ahead and try those problems, and I'll get back with you. Oh, hang on. Of course, this is 3n as well. Okay, just do the multiples of 3. That will give you some to do on your own, and some you can look in the book and check your answers. Whoops.